Hello students, this is Unit 4, Lesson 2. We are adding and subtracting rational expressions today. Remember, rational expressions are fractions with polynomials in the numerator and or the denominator. In our last lesson, we simplified, multiplied, and divided rational expressions. In this lesson, we're adding in a step. We have to find a common denominator, just like we do with regular fractions with just numbers. So really quickly, I just want to review a couple of concepts that you would have learned in elementary school and middle school. These are things that we're going to be using as we go through this lesson. First of all, equivalent fractions. Equivalent means equal. So if we're trying to write a fraction that's equal to or equivalent to 2/3, what we can do is multiply the numerator and denominator by the same number. So if we multiply, let's say we multiply both of these by 4. As long as we're multiplying by 4 in the numerator and denominator, that's really just like multiplying times 4 over 4. 4 over 4, or 4 divided by 4 is just 1. So what that does is it doesn't change the value of this fraction, it just changes the name of it or the look of it by multiplying by 1. So the value is the same, the two fractions are equal to each other, so 2 out of 3 is the same as 8 out of 12. 8/12 is just a different way to write 2/3. We can multiply times anything as long as we do the same thing in the numerator and in the denominator. Simplifying fractions, if we have something like 12/18, what we need to do is we need to look for a common factor between the numerator and denominator, and you guys know how to do this. You also know you can put it in your graphing calculator and get the answer. So if I find a common factor between 12 and 18, well, 2 would be a common factor, but they also have a common factor of 6. That's the greatest common factor between the two of them. So if I just divide by 6 in the numerator and 6 in the denominator, again, I am dividing by 1 because 6 over 6 is 1. But if I divide both of these by 6, I'm not changing the value, I'm just simplifying it. A lot of people use the word reduce, and reduce to me is not an accurate word because reduce means to make something smaller. We're not making this smaller, we're just simplifying it. 12 divided by 6 and 18 divided by 6, and we're back to our 2/3. These are all equivalent fractions. 2/3, 8/12, 12/18 are all equivalent to each other, or equal to each other. Least common multiple, we're going to be looking at least common multiples of some expressions today. Least common multiple and LCD, or least common denominator, are really the same thing. If I need to find the least common multiple of 6 and 8, I could, well, a common multiple, I could just multiply them together. So if I multiplied 6 times 8, I would get 48, and that is a common multiple. And that works when you're adding and subtracting fractions. But if you want the lowest one, with numbers, a lot of times it's easy just to list out the multiples, and then the first one you get to that's the same or common, but you know common in math means the same or like, that's it. So if we just listed out multiples, and multiples are numbers that the number divides into. So 6 times 1 is 6, 6 times 2, 6 times 3, 6 times 4, and so on. If we just list out a few multiples of 6, and then we do the same with 8, and we just look for the first one we come to that is the same for both of them. So the LCM or LCD, if they were denominators, would be 24. There's another way to get the least common multiple, and it's using prime factorization, and you might have done that when you were in elementary school also. But sometimes it's just easier to just think, okay, let me just list out some multiples and see if I can figure this out. Now, over here where we're reviewing adding and subtracting fractions, if my least common multiple is 24, what I need, because my denominators are different, when you add and subtract fractions, you have to have the denominator the same. So what I need to do is I need to get a denominator of 24. For each of these. I'm going to have to multiply times something to get that 24. And over here I'm going to have to do the same thing because I need my denominator to be the same for both of these. So then what I can ask myself is, well, what do I do to this to get this 24? Well, I multiply 6 times 4. So as long as I multiply by the same thing, numerator and denominator, I will get an equivalent fraction to that 1/6. I also need an equivalent fraction to the 3/8 with a denominator of 24. I'm sorry, I wrote that 24 in the wrong place. It should have been over here. So what do I do to 8 to get 24? Well, I multiply it times 3. As long as I multiply times 3, numerator and denominator, I'll get the equivalent fraction to 3/8. So let's do that. Let's see, 1 times 4 is 4. And then 3 times 3 is 9. So these are my two fractions that I can add together now, 4/24 and 9/24, because they have common denominators. So 4 plus 9 is 13. And I keep that denominator the same. You don't add together the denominators. You don't multiply them or anything. You just keep the same denominator. So 4/24 plus 9/24 is 13/24, which also means 1/6 plus 3/8 is 13/24. So these are some simple steps for adding and subtracting rational expressions. You can write these down, but I'm actually going to keep these in a smaller version on the next few pages, on the next few slides anyway. So if you don't get them written down, you'll still see them. Notice number 2 says create a common denominator. It does not say an LCD or a least common denominator. It's not necessary to create a least common denominator. It's just helpful at the end when you need to simplify. So create a common denominator is step 2, and then you see steps 3 through 5. I'm not going to read them out for you. We will have them on the next couple pages. So you see I have the steps over here smaller for us so we can just refer back to it if we need to. So here's an example, 13a over 4a squared and 5a over 4a squared, and we need to add these together. The denominator is the same. So we're, factor denominators. There is no factoring to be done here. I can't factor one term. Step 2, create a common denominator. It's already common. It's already the same. Now it says add or subtract the numerator. Now, I'm going to tell you these could be simplified before we add them, but we're just going to go ahead and add and then simplify them after we get finished. Add or subtract the numerators. So 13a plus 5a is 18a. Keep the denominator the same. 4a squared. Do not add those together. 4a squared is the denominator. It stays the same. And then if you can factor, you do that, and then you simplify if possible. Well, I can actually simplify this. 18 and 4 have a factor of 2 in common, so I can divide by 2, both of those. And then a and a squared, they will cancel. Divide by a here, that's a 1. Divide by a here, a squared divided by a is a. So my answer is 9 over 2a. So my denominator started out the same, so it was really easy. Just add across the numerators and then simplify if you can. Okay, so step 1 says factor denominators, which we can do, but we actually don't really need to do that yet because they're common denominators. So we really could just go ahead and bring over this denominator. We will factor it eventually. But we can go ahead and just bring it over. And then we can add like terms here, y squared. I don't have another squared term. I do have 2y terms, so 8y plus 2y is 10y. And then 21 is my constant. So at this point, I need to use my rules for simplifying. So I need to remember how to do that. I need to factor the numerator and denominator. When I factor the numerator, I get y plus 7, y plus 3. As my factors, and then I also need to factor the denominator. That's a difference of 2 squares, so that's going to be y plus 3 and y minus 3. This is why we can't leave it like this. We need to factor to see if we can simplify, because you see we have a y plus 3 in the numerator and denominator that we can cancel out. So then we do that, and our answer ends up being y plus 7 over y minus 3. Okay, one more like denominator example, and then we'll start looking at problems that have different denominators. So we have the same denominator here, so we can combine like terms in the numerator. And let's just go ahead and rewrite our denominator. We will have to factor that in a minute, but let's add 13k squared and k squared. That's 14k squared, and negative 9k and 2k. That would be negative 7k. So I need to simplify this. My denominator is a trinomial with a greater than 1. So I need to split this middle term to factor this. So I'm going to look at 6 times 1, which is 6, and then my middle term is negative 5. When I look for two numbers that when I multiply them I get 6, positive 6, and when I combine them I get negative 5. That's going to be negative 3, times negative 2, negative 3 plus negative 2. So I need to split this middle term. I'm gonna do this work over here. So I'm gonna rewrite the whole thing, but instead of writing this negative 5k, sorry, my highlighter didn't want to come up. So instead of writing negative 5k, I rewrote it as negative 3 and negative 2k, and that still equals the negative 5k. So then we want to split this down the middle, and we're going to find the greatest common factor of this side, 3k. And then in parentheses, we have 2k minus 1. And then over here, I'm going to take out a negative 1 because I want this 2k minus 1 to be the same thing over here. So I'm going to do minus 1. Okay, so this is one of my factors, the 2k minus 1. And then what's left over, the 3k minus 1, is the other one. So when I factor this, I need to factor my numerator also. I'm going to take out let's take out a 7k. That's going to be 2k minus 1. And I'm going to have something to cancel out here. So this one is the denominator. It's 2k minus 1 and 3k minus 1. We can cancel those. So our answer, and look, I want you to understand you cannot cancel this and this. This is in parentheses. You can only cancel whole entire factors. So the 2k minus 1 canceled because they were exactly the same in parentheses. So my answer is 7k divided by 3k minus 1. I'm going to put that in parentheses so that it makes it a little bit easier to see, in my opinion, that I can't cancel those 2k's because I can't cancel the whole factor. If this was just 3k, then I could cancel the k's, but the factor is 3k minus 1. So now we want to look at some problems with different denominators. I want you to really notice that this is minus, so if we get something else over here that's an expression, we need to make sure that we put that in parentheses and then distribute that minus, and I'll show you if that happens. My first step, factor denominators. I need to factor the denominators. I need to rewrite this like that, because I need to find my common denominator, but I might not have to just multiply this whole thing times this whole thing. Okay, so let's rewrite. Okay, so this is how this works. I'm going to look at my denominators. I went ahead and I factored the 5k minus 10. I factored out a 5. So I like to use highlighters. If you watch my videos, you know I like to use highlighters. So I'm going to highlight, maybe, what these two denominators have in common. They both have a k minus 2. And then I'm going to highlight in different colors what they don't have in common. Well, this one has a 5 and this one doesn't have anything else. Okay, so my common denominator is this, 5 times k minus 2. It's the green and the yellow. Okay, so I see that this denominator on the left has both the green and the yellow. The denominator on the right only has the yellow. It needs the green to go with it. Okay, so what I would do is I would multiply it times the green part of the denominator. Well, if I do that, if I multiply the denominator times something, I also have to multiply the numerator times something. So then I go back and I say, okay, what was the green number? Well, the green number was 5. Let's see if I can get my pen. So the green number was 5. So I need to multiply this fraction by 5 over 5 to get an equivalent fraction with the same denominator as the one on the left. So that's what I'm going to do. I'm going to multiply the 4 times the 5, and I'm going to rewrite, and I'm going to pause my video and then come back. So here's what I did. I rewrote the first fraction, the one on the left, and the second fraction, I multiplied the 4 times the 5, and then I multiplied the 5 times the k minus 2. You can keep it like that. You don't multiply that 5 into there. You don't have to do that. So now you see both denominators have both green and yellow, so they have their common denominators. Now, I need to add the k squared plus 16 minus 20. Keep in mind, this is a minus, so I'm going to change that to a negative 20 so we just don't get confused and add 20 to that. So I'm going to add those numerators, k squared minus 4. And then this denominator stays the same. Now, what does it say? Number 4, factor new numerator if possible. I can factor this numerator. This is the difference of two squares. This is k plus 2, k minus 2, and guess what? We have a k minus 2 in the denominator. So now I can simplify by marking that out, and my answer is k plus 2 over 5. Here we have another subtraction problem where we have different denominators. We can't, step one, we cannot factor the denominators. They're already in simplest. They're already factored. So create a common denominator. Well, what do I have? I have a, excuse me, I have a b plus 3 and I have a b. Well, they don't really have anything in common. This is an entire factor, so I can't say, oh, they have a b in common. That doesn't work that way. So what does... What is not greatest common factor. What does the least common denominator look like? Well, it has yellow in it and it has green in it. So the least common denominator is going to be the yellow times the green. Okay, so what does this one have? It has the yellow, it needs the green. So I need to multiply the denominator times the green and the numerator times the green. This one over here has green, but it doesn't have yellow, so it needs the yellow. To put the yellow down here, got to put it up here too. So if you're getting this without all these colors, you're welcome to fast forward through this stuff. Okay, so this one needs the green, that's b. So I need to multiply b over b. And here I need to multiply b plus 3 over b plus 3. All right, let's do that. b times b is b squared. And then the bottom, I can leave this factored, which is what I really want to do. This is going to, and I'm going to go ahead and multiply in the 4 here. In the numerators, you want to go ahead and use that distributive property. Denominators, you can leave them factored. Okay, so that's 4b. Actually, you know what I'm going to do? I'm going to change this to plus negative 4. And then I'm going to distribute in that negative 4, and that'll make it a little bit easier. Minus 4b minus 12. Okay, so got my denominators the same. I need to add my numerators together. There's nothing in common. There's no like terms I can combine. So it's going to be b squared minus 4b minus 12 over, and then leave this b times b plus 3. What's my next step say? I added and subtracted the numerator, kept the denominator the same, keep it in factored form. Factor new numerator if possible. Yep, this is a trinomial, and it's pretty easy to factor. It factors to b minus 6 and b plus 2. And then the denominator, same thing. I can't simplify that in any way, so this is actually my answer. Or you could leave the answer like this. You can go back to that answer if you want to, because it can't be simplified. All right, this is a fun example. We have two denominators that can both be factored, and that's our first step. So I'd encourage you to pause the video and see if you can factor these. Just rewrite them. So rewrite the 2 over, factor this, plus the p minus 6, and then factor this denominator. So this is what you should have gotten. 4 times p minus 5, and then 2 binomials for this one here. So let's look at the denominators and let's figure out how we can do the least common denominator. So what I want to do first is I want to highlight what they have in common, and I did it again. I want to highlight what they have in common, the p minus 5 in the same color, okay? And then the other things that they don't have in common, I'm going to give each of them a different color. So the 4 gets green and the p minus 3 gets teal. They both have the yellow, so neither one of them needs the yellow. But the least common multiple, or the least common denominator, is going to be yellow, green, and teal. So it's got to have all 3 of them, okay? So this one over here, what does it not have? It doesn't have the teal. So I need to multiply times teal over teal. And then this one over here doesn't have the green. So I'm going to multiply times green over green. Okay, so this one I'm going to multiply times p minus 3. Again, with the denominators, leave them in factored form. Don't worry about multiplying all this out. You're not going to do that. Multiply times p minus 3 in the numerator also. This one I'm going to multiply times 4. Okay, so what I want you to do is rewrite this and multiply the numerators and get new numerators. So now all of the denominators have green, teal, and yellow, and I multiplied the 2 times the p minus 3, and I multiplied the 4 times the p minus 6, and again, you do want to multiply those out because we need to combine like terms up here on top. Let's see if I got a pen. Yep. Okay, so let's combine like terms. 2p plus 4p is 6p, and we'll put this over here. And negative 6, negative 24, negative 30. And then just keep your denominator. Now, what's my last step, or my second to last step? Factor new numerator if possible. Yep, we can factor this. We can take out a GCF of 6. P minus 5 can be canceled out. So my answer is 6 over 4 times P minus 3. Okay, so I have an example here I would like for you to try. I would like for you to pause your video and see if you can get this one and then come back and see if you got it correct. I do want to caution you though that this is minus. So you could change this to plus negative 8 and that might make it a little bit easier to work with. So pause your video and then come back. Okay, so here's the answer, r minus 4 over 2r. So I needed to multiply times r on this side and times 2, excuse me, on this side. And r times r is r squared. Negative 8 times 2 is negative 16. Well, this is r squared minus 16. I wrote it that way so we could see it's a difference of 2 squares. And then the numerator, and I also highlighted these down here so you can see that they have the same denominator now. The numerator can be factored into r plus 4, r minus 4, and then those r plus 4s can be canceled out. And so your answer is r minus 4 over 2r. I wanted to show you an example like this. This is not an addition or subtraction problem, but if you end up with an answer that looks something like this, this can still be factored, and I wanted to just show you. This is still difference of 2 squares. This is 4 plus r times 4 minus r. And you might think, oh, I can cancel all of this out and it equals 1. It actually doesn't equal 1. You can cancel 4 plus r and r plus 4 because addition is what we call a commutative property. We can switch the numbers around and it doesn't change the value. So 4 plus r equals r plus 4. So yeah, we could cancel these out. 4 minus r and r minus 4 do not equal the same thing. However, what I want you to understand is that anytime you have an a minus b over a b minus a, that just equals negative 1. To show you how that works, if I pulled out, let's say I factored this and I took out a negative 1. So I'm going to factor this 4 minus r. I'm going to take out a negative 1. Well, 4 divided by negative 1 is negative 4. Negative r divided by negative 1 is positive r. Okay, now negative 4 plus r can also be written as r minus 4. So as long as I pull out a negative 1, then I can cancel these. So anytime you get something that's reversed like that, if it's subtraction and the two numbers are reversed, so if you've got x plus 2, I'm sorry, not x plus 2, x minus 2 and 2 minus x, just keep in mind that's negative 1. N minus 3 over 3 minus n, negative 1. So just put a negative somewhere in the numerator or denominator and you can cancel those out. So up here again, if I'm looking up here, if I just put a negative 1 somewhere on the outside, then these two things can be canceled out. So the answer to this would actually be negative 1. So just keep a lookout for that. If you see something like that, addition, it doesn't matter what order they're in, you can cancel them out. But subtraction, if they're reversed, then just remember, take out a negative 1 from the numerator and then you can cancel them out. Okay, I think we'll try one more. If you want to pause your video and come back, I'm going to pause and I'm going to work this out and then I'll bring you back with the answer. Okay, so the answer is p minus 2 over p minus 5. Factored this denominator into p minus 9, p plus 5. They both have the p plus 5 in common. This one needed the p plus 9 multiplied into it. I also changed the minus to a plus and changed this to negative 2 because I think it's easier to distribute that into these parentheses if it's already that negative. So I did that, just brought this one down here and I multiplied the negative 2 in. So I got negative 2p plus 18, and then I combined like terms. So I had a p squared term, I had negative 2p, negative 9p, that's here, and then the 18. So then step 4 says factor new numerator if possible. So that's what I did. I factored that into p minus 9, p minus 2, canceled out the p minus 9s and got what I had left was p minus 2, p minus 5. I want to remind you too that if you cancel everything in your numerator, you have a 1 left over. You don't have nothing left over in the numerator. You have a 1. All right, I think that'll do it. Our next lesson is going to be complex fractions.